Okay, so let's look at chapter 1. We'll study the units. This is units and measurements. So what's physics about? Um, it turns out the laws of physics describe everything, describe the behavior of everything, from galaxies to atoms. And so laws of physics apply across the board. Um, and It turns out that, well, I mean, one would think that in nature there are so many different phenomena, so you'd think that nature is pretty complex. But it turns out that there are surprisingly few laws of physics, implying a simplicity to nature, even though it appears complex. All right, so what we are saying is the laws of physics applies to everything from atoms to galaxies, and there are only a few laws of physics, implying that nature is underneath its complexity. It's pretty simple. So here are three pictures just to illustrate this fact. Okay, here's a picture of an array of atoms. So these each dots are atoms. Atoms are roughly 10 to the minus 10 meters. That's the size of an atom, 10 to the minus 10 meters. This is a picture of phytoplanktons, and the size of a phytoplankton is a micrometer, 10 to the minus 6 meters. Okay, so these are roughly 10,000 atoms across. Okay, so that's the size of these guys. And these are two colliding galaxies, and they're located 300 million light years away. Anyway, so these are two large objects. And now the point is, so the laws of physics apply to all these objects of very different sizes. Okay. By the way, interestingly, these two galaxies are colliding, and the same laws that apply to colliding billiard balls apply to these colliding galaxies as well. Okay. All right. In physics, we do a lot of measurements to verify laws and stuff and things like that. And now the units in which we make measurements are called the SI units. Okay. So this is a set of units agreed upon by scientists, and this is called this is called the System International Units of Units. Okay. Now it turns out that in science, every quantity in science can be expressed in terms of 7 basic quantities. So 7 quantities were picked to form the basis of the International System of Units. So, and these are the 7 quantities. For length, we choose the unit, we measure length in meters, mass in kilograms, time in seconds, electrical current in amperes, temperature in Kelvin, and the quantity of stuff in moles, and the intensity of electromagnetic radiation in candela. And it turns out that every unit of interest, every quantity of interest can be expressed in terms of these 7 quantities. Yeah. This semester, every quantity we talk will require only these 3 basic quantities: the length meter, time measured in seconds, and mass measured in kilograms. So everything we talk about can be expressed in terms of these 3 quantities. So here's a list of various quantities that are measured. So for instance, energy, the SI unit for energy is the joule. That's called, and that's denoted by J. The joule is meter square kg per second square. So as we said, this quantity that we are interested in can be expressed in terms of those 3 quantities. Now here's a comment about the units. combinations of basic units in physics are named after scientists. So Mr. Joule worked in this field, and so this combination of units is uh, is named after him. Here's another example you might be familiar with. The combination meters kilogram per second square is named Newton after Sir Isaac Newton. All right, let's talk about prefixes. Okay, so here's the idea. Um, the SI unit for length is a meter, but for instance, if you wanted to know the distance to New York City uh, from from let's say Daytona Beach, the distance to New York City is you don't want to express it in meters. You get a very large number. So appropriate unit, a good unit for this measurement would be a kilometer, which would be and here's how the prefixes work. So this prefix stands for a power of 10, and that prefix stands for the power of 10 to the power of 3 meters. So here's the meter is the basic unit, and you apply a prefix, the kilo standing for 10 to the power of 3. So all these various prefixes stands for these powers. So for instance, if you wanted for some reason um, a megameter, a megameter would be 10 to the power 6 meters. Okay, so that's how the prefixes work. Here's a common prefix, 1 micrometer, a common unit. So the micro prefix is 10 to the minus 6 meters. Okay? So 10 to the minus 6 meters. And this is a good unit to measure cell sizes and stuff like that. Okay? So if you're a biologist and you want to talk about the size of a cell, that's a good unit. So that's what these prefixes are about. All right. Now we'll talk about time. One of the 3 basic units we're going to use this semester. Okay, but let me stop this recording for now.